All right, I'm going to explain to you what we did in class when I was standing here and I was swinging that object around my head. And we would just say that, let's say I'm holding this piece of string and I'm swinging this Nerf soccer ball around my head. And it's moving, we'll just call it counterclockwise. So if we treat this and look at it, what's going on in terms of circular motion piece. Let's say here's the middle, and here's the ball, and here's the ball, and here's the ball, and here's the ball. And it's moving counterclockwise. Here's what we need to look at. If we're going to study the concept of centripetal force, we have to acknowledge that it's actually the tension in the string that's actually going to be providing the centripetal force, right? Where there's a centripetal force, where an object is moving in a circle, a centripetal force is present. And that means something very specific. That means that the tension within the string itself is actually always going to be pointed inward, right? That's the force of tension. That if I were to, let's just say I were to happen to, if this were to break or let go at this point right here, that Nerf ball would just keep on traveling in a straight line because that's the direction in which its velocity, right? That's the direction it's traveling. And we're going to start using this term. It's perpendicular, but generally it's referred to as tangential. So it's essentially tangent or tangential to the net force here. So that means if there's a net force inward, it's also accelerating inward. But remember that in order for something to be accelerating, it can be either speeding up, right, increasing in velocity, or it can be decreasing in velocity, or it can be changing in its direction. And this is key here, because now for circular motion, we're actually looking at, this could be swinging around my head at a constant velocity, yet it's accelerating. It's accelerating because it's changing direction. So an acceleration has three different ways in which we can be accelerating an object. So here's my picture that I'm emphasizing to you. That in this case here, if this were swinging around, right, swinging really fast, and let's say the string broke right here, this would continue traveling in a straight line that's tangential to the net force, or the force of tension. And if it were to break right at this point right here, it would continue traveling in a straight line, right? It's tangential. So the velocity is perpendicular to the net force of the force of tension. So let's draw this and let's apply it a little differently. Let's say we're talking about a planet orbiting a star, right? Let's call this here a star. And let's say here's a planet. And the planet, right, in this case here, you have a net force, and this force would be the force of gravity. That planet is accelerating, right, towards where the net force is located. And in this case right here, right, we've got F of G. F of G, force of gravity, is providing the centripetal force. So we have, in this case, here we have the force of tension providing the centripetal force. Here we have the force of gravity that's providing the centripetal force, right? Once again, if the star or that star were to just go away, let's say this is moving counterclockwise also, that planet would continue traveling in a straight line. Now, that's hard to believe, but it's just, something funky, not very realistic. But its velocity is always perpendicular or tangential to the net force. Last but not least, the one thing I had you do in class, we should have ended with, is where you should have actually had a chance to walk and run around the corner. And we had students kind of lined up here, and you're kind of the bank boards. So what happens here is that when you run around here, you'll find that it's actually the force of friction, right? Where you have your shoes on, the shoes have a very nice force of friction, a much larger amount of friction. The force of friction is what is providing the centripetal force. And when I had you take off your shoes and you were just in your socks, you actually have less friction, right? If you have less friction, then you may not have enough friction. You may not have enough of a centripetal force that's providing you, right? It's inward. And that's the cool part about it, is that you can actually feel that. You actually feel the result of inertia. So as you're turning the corner here, if you slip and fall, you're going to slip and fall, and you're going to travel in a straight line because of your inertia, right? That's the direction of your velocity. And this here, the reason why you travel tangential to it is a result of your inertia. And these are the three topics we have looked at and begun studying in our topic we're at today.